Hi, today we're going to talk about the distance formula, and this is Unit 15-6, Day 1. Here we have the distance formula between 2 points. D stands for distance. We'll need 2 ordered pairs. This is the distance formula that we will use. Looking at this graphically, here are your 2 points. The hypotenuse of a right triangle. This is D, distance. Now where does it come from? Alright, suppose we had the ordered pair 1, 3. So 1, 3. And the ordered pair -2, -2. And this is going to be the hypotenuse. If we connect to form a line, or a triangle, sorry, count the units 1, 2, 3. So this would be 3. 1, 2, 3, 4, 5 would be 5. So we can find the distance between the 2 points. To do this, since we have a right triangle, we can use the Pythagorean theorem. Plugging in, either side could be A, but I'm going to let 3 be A, so 3 squared. B is 5 squared. For C, I'm going to plug in D for distance squared. 3 squared is 9. 5 squared is 25 equals D squared. 9 plus 25 is 34. And to solve for D, the distance, we can take the square root of both sides. So the distance, 34, you could break down into 2 and 17. So that would just leave us with the square root of 34. Alright, let's look at a couple of examples. It says find the distance between the 2 points, and we want to leave these final answers in simplified radical form. So simplified form, which is radical form. So number 1, suppose we had the ordered pair -1, 3, and the ordered pair 5, 2. Using the distance formula, I suggest that you label the ordered pairs x1, y sub 1, x sub 2, y sub 2. And plug in the values now. So sub these in. X sub 2 would be 5 minus x sub 1, -1 squared, plus y sub 2 would be 2 minus y sub 1 is 3. Continue to simplify. 5 minus a -1 is 5 plus 1, which is 6 squared. 2 minus 3 is -1 squared. 6 squared is 36. -1 squared is 1. And we get the square root of 37. And this will not break down anymore. So the distance equals the square root of 37. Let's do another one, number 2. Using the ordered pair 8, -7, and the ordered pair 4, -3. Let's use the distance formula. to label my ordered pairs, x of 1, y sub 1, x of 2, y sub 2. So subbing in 4 minus 8 squared plus negative 3 minus negative 7 squared. Continuing to simplify, 4 minus 8 is negative 4 squared plus negative 3 minus the negative 7 is negative 3 plus 7, which is 4 squared. Negative 4 squared is 16. 4 squared is 16. So 16 plus 16 is 32. This does reduce more. So if we continue to simplify the radicand, for 32 we could do 2 times 16. 16 is a perfect square. The square root of 16 is 4. 2 you can't do anything else with. So 4 square roots of 2 is equal to the distance. One more using the distance formula. Let's use the ordered pair negative 1, 4, and the ordered pair 12, negative 5. Label your ordered pairs and plug these in. Simplify your radical. 12 minus negative 1 is 13. Negative 5 minus 4 is negative 9. 13 squared is 169. Negative 9 squared is 81. 169 plus 81 is square root of 250. And reducing this, I could do 2 times 125. 125, I could do 5 times 25. The square root of 25 is 5. 2 and 5 you can't do anything with, so 2 times 5 is 10. So your distance is 5 square roots of 10. Alright, let's look at a word problem. It says a student is taking the bus home. The student can get off at one of 2 stops. Which stop should the student take to get home quicker? Justify your answer. So let's look at this. Alright, looking at the ordered pairs, stop 1 has the ordered pair 0.5, 0.5. Stop 2 has the ordered pair 1.5, 3. And stop 3, or not stop 3, but home, has the ordered pair 2.5, 1. And the x-axis you're counting by 0.5s, the y-axis the same. Units are miles. So if we look at the student can get off, student's taking the bus home. So if we look at stop 1 to home, find that distance, then look at stop 2 to home, look at that distance, and compare the two distances to see which one is the shortest distance. Alright, so let's look at stop 1 to home. Alright, stop 1. And the ordered pair for home. Labeling these. Sub these into the distance formula. So x of 2 minus x of 1, y sub 2 minus y sub 1, simplifying, 2.5 minus 0.5, we get 2 squared. 1 minus 0.5, we get 0.5 squared. 2 squared is 4. 0.5 squared is 0.25. Adding together, we get the square root of 4.25. Now when we talk about miles, we don't say the square root of 4.25. We would approximate this to a decimal. So if you take the square root of 4.25, you get approximately 2.06 miles for stop 1 to home. And if we compare stop 2 to home using the same process, stop 2, and then the ordered pair for home, label, and plug into the distance formula. X sub 2 minus x sub 1, this difference squared, plus y sub 2 minus y sub 1 squared. Simplifying, we get 1 squared plus negative 2 squared. 1 squared is 1, negative 2 squared is 4. So we get the square root of 5. Again, when you talk about miles, you wouldn't say I walked or I rode the bus, square root of 5 miles. We would approximate this. Square root of 5 is approximately 2.24 miles. So which stop should the student take to get home quicker? Stop 1 has the shortest amount of miles. So we would say the student should take stop 1. If you have any questions, you can let me know, you can let your teacher know, and we'll be more than happy to help you with the distance formula. Hope each of you have a great day.